For part 2 of our lab for x86, we're going to be looking at a lot of this right here. So for this, we are going to be looking at these sets of instructions. Now for our hand assembly lab, what we're going to do is we need to choose a register to implement our statements. And when we choose our register, at least for me, we're going to be doing it based on the first and last name. So with our first letter of the last name being S, which is what mine is, we cannot use the D register. So we're going to have to replace that. And I'm going to replace it with the C register. And then for our first name, we're going to have to choose a register in here that we need to use for our memory location for the start. And mine is going to be a B, so it's going to be memory location 554. So up here, we're going to be using the memory location where we have, well, we cannot use our D, so we can't use D in here. And then in here, we are going to use 554. So one thing we cannot use, and then one thing we have to use. And that is it for that part right there. Now we're going to write our code. So in the code, I have some notes. We have all the part 1 stuff that we did here, and now part 2. We are converting the program from 16-bit to 8-bit. So that means instead of using the CX register, we're going to be using the CL register, which only has 8 bits. We're going to grab 1 byte of data at 0554, and then we see 0555. Previously, we have a gap in our registers because our A of X can grab 200 and 201, and then the B of X grabs 202 and 203. But we're only concerned about the single 8-bit of data right here, or the 8 byte. And so when we look at this, this is our program. We have to modify this program. Not only do we have to choose and not use a specific register, we have to modify our program. Previously, if we look at our flowchart right here, we have this flowchart, and that is in a different video, and that is in the description with the playlist. But this flowchart tells us what we are coding for the entire first part, how that works. Now, the difference for this one is that we can only use one conditional jump statement. So in here, we see we have a conditional jump statement right here, JGE, and we have a conditional jump statement right here. Now, we can only use one. So what I'm going to do is modify one of them. If we look at this one, we're checking if our A of X, and we are going to have to switch the registers because this is different. We're coding for 8-bit than 16-bit. But for now, we are just going to write, we're just going to leave the naming as is. So if it's positive, it's going to go and it's going to end. If it's negative, it's going to go down here. It's going to go to here. Now, we have another jump statement right here, where if it's positive, it's going to go here. Otherwise, it's going to go back to here. Well, that's a little bit redundant. Instead of doing that, what we can do is always go into this unconditional jump statement. So we add here, and then we always go to this unconditional jump. And this unconditional jump is going to take us back up here. And that is going to be our check. So instead of checking here, we're always going to fall through the unconditional jump and then jump back through here. So what we can do is delete this because we are no longer going this way. So we're going to take this out. We're going to take out this jump because we are not going to be going through here back here. So that link is broken, and we're just going to be taking this out. This is done, and this is done. And we no longer need this. Now from here, what we want to do is change this jump statement. So what we can do also is we're going to, we can make this arrow bigger, or we can just move these values. So we're going to move everything up here. We're going to take this, we'll delete this, and delete this, and instead we're going to say if it's positive, we're going to go here, because we know where that we're going to go here. And then for this one, we are going to, we have this unconditional part, that's okay. We're going to take this wire, and we're just, not wire, but this part of the diagram, we're going to move it up. And same thing with this one, we're just going to move this one up as well. And this command is for this part right here. Everything else other than that should be the same except for our names. So since we're dealing with 8 bits, and we cannot use the D register, that should be in notes. Since we're dealing with this, we are going to be inside of here. So what we're going to have in here is a move CL, and inside of our CL, we can't use 120 because that is a 16-bit register. 120, or it's more than what we're able to use. So if we use 20, which is 8-bit, we can put this in here. So into CL goes our 20, and we're going to change this as well. We are still moving a constant 20 to our CL register. Now from here, we are going to move, and we have to change this A of X. We cannot use A of X again because that's 16-bit, and we're changing this up. We want to move A of L because A of L is our lower bit. AX is 16-bit, L or H stands for low high, and that is 8 bits each, compromising to make the 16-bit. Inside of here, we're changing our address. This is based on our first name, so we're going to have 0554 for my name. We're going to move register 0554, and I can just write 554 to keep it short in here to our AL. This is not capital, so I won't capitalize this as well. And we have our AL here. So those are our two moves, and now we're going to do the same thing, but for our B of L. So into our B of L is going to go a 0555. And this one is going to change as well, 555, into our B of L. We're going to go down another one. And so subtracting, we want to check these. So we're going to subtract our B of L from our A of L. And then we know that we are going to store it inside of our A of L. So we're going to subtract A of L, comma, B of L. And then we can end this code, and we're going to go straight into our jump statements. So our first jump statement, we are checking if not our A of X, but we're checking if our A of L is positive. So we would jump greater than or equal to, and this part in our code is going to be 111. This code is already done out for us, but if we needed to, we would probably have to use the debugger to actually find and look for the address, but also not really, because we have like 100 here, 102, 103, 104, 105, 106, 107, 108, 109, and we would be jumping through here. I might have read that wrong, but we should be jumping to the end here if we have 111. If not, we can always change that. And then that's if it's positive. We are jumping to the very end right here. If it's positive, we're going to move into our register 0554, the A of L. And so we're going to note that inside of here, where we have our 0554 into register A of L. That's going to be this register, and then we're going to end our program here with the int 22. So unconditionally, we're going to jump back into our program. This is our JMP command, where we have 10b, and that is the location that we're jumping back to, which is going to be, should be about right here, where we have our jump greater than or equal to, and that's going to check. So we have our, if it's negative, we're going to go inside of here, and we are going to, and this command should be associated with this. We're going to add register, and then we're going to add AL to CL and store the location, or the result, sorry, in A of L. And then in here, we're just going to note that, where we have our A of L and our C of L inside of here. And so that should be our flowchart updated. And it's slightly smaller than the previous one, and that's because we have one less statement. But it should work just the same. This is just with 8 bits. And so that is the code for this, for the flowchart, for the code that we're going to be using. And now we can work on the second part, which is a little bit different. And instead, it's going to be the part 4, I believe, part 4 and 5.